Hi students and welcome to the class. The first thing you need to do is, you need to go to the website aplusstudents.com. Okay. Once you're on the website, okay, you need to select math as your subject. Okay. This is a grade 9 math lesson. Okay. And the name of the topic is probability. And the chapter number and the lesson number is, I'll give you the chapter number. The chapter number is 10 and the lesson number is 2. Chapter number 10 and lesson number 2. Today we would be looking at, the name of the lesson is theoretical probability. Okay, so let's go to the chapter. The first question, okay, whenever we are trying to find the probability, I'll give you an introduction. Anything that happens is an event, like turning on the switch, picking up your phone and looking whether you have a message or not, right? Calling someone, they will answer or not. Everything that happens is an event. So we say event, the definition would be anything that, anything that is happening around, right? That is an event. The probability of any event, the P means the probability of any event, anything that is happening, the probability of an event cannot be less than 0. If it's 0, that means it's not happening, right? If it's 1, it happened, right? So probability of an event, anything happening can be between 0 and 1. It cannot be less than 0 or it cannot be greater than 1. How we can find the probability of any given event is, the formula for the probability is, we say favorable outcomes I'll explain this. Outcomes divided by total number of outcomes. Okay. Let's look at the first example. Okay. This is the basic information that we need to remember about probability. Okay. Probability, the word probability can be replaced by possibility or by the word chance. We are trying to find the chance of occurrence, right? What is the possibility of you getting full marks? What is the probability? What is the chance of you, right? So these three words are synonyms of each other. They can be used interchangeably. Okay, let's see. The question 1 says, just a moment, please. For the question 1, you flip a coin. Okay. In question number 1, they're saying you flip a coin. A coin is given to us. What is the probability of tail? Give your answer as a percentage. Okay, let's see. for question number 1. If we know that on a coin there are two possibilities, right? We can have a head or a tail. That means the first thing we do is we write a coin and we write the possibilities. We can have a head or we can have a tail. Can we have any other possibility on a coin? There are no other possibilities on a coin, right? There are only two possibilities on a coin, heads or tails. If we write head and we say tail, okay? So if we need to find the probability of head or probability of, or if we need to find the probability of tails, how many tails are there on a coin? There is one tail that is favorable outcome. Upon the total, how many outcomes were there? There were two outcomes. Agreed? Similarly, if we need to find the probability of heads, how many heads are there on a coin? There is a single head. One side is head and one side is a tail. That means head is also 1 upon 2. Agreed? So that means when we have two options, they both are half and half, right? What we had to do was we had to find the probability of tail and write it as a percentage. So what we did over here is we found the probability of tail, that is 1 upon 2. And when we need to change 1 upon 2 as a percentage, so we can say 1 upon 2 multiply by 100%. This was the probability of tail as a percentage, right? So that means 100 divided by 2%, right? 100 divided by 2%. That means it comes out to be 50%. That's why we say the chance of getting a tail and the chance of getting a head is 50-50, right? That means 50% chances that you'll get a head and 50% chances that you will get a tail. See, if you have a coin, you have not flipped it yet. So there are two options only, right? It can be a head or it can be a tail. That means each of the options have a 50% chance that they would land on a head or it would land on a tail. Agreed? Okay. So let's see another example. For the next question, it says a spinner is given to us, right? A spinner is like some partitions on a circle are made. There is a needle in the center. We spin the needle and we get a outcome. So let's look at this experiment. I'm so sorry. Okay. If this experiment says you spin the spinner once, you have a spinner. The spinner has an arrow on it, and we spin the arrow. And they're saying find the probability of a prime number as a percentage. Okay? Find the probability of a prime number as a percentage. So the first question is, what is a prime number? Right? Prime numbers are only divisible by themselves and by 1. And we know that smallest prime number is number is 2. 1 is not a prime number. Okay. So we have options over here. We had 2, 3, 4, and 5, right? If you spin the spinner, what are the possibilities? If you spin the spinner, so we can say if we spin the spinner, the possibilities for the spinner could be we can land it on 2, we can land this needle can land on 3, 4, or 5. There is no other option, right? Out of these 4 options, the needle will land on any one of the options, right? We need to find the probability of prime numbers. Let's see how many of these out of these numbers are prime numbers. If these were the possibilities on the spinner, how many numbers are prime numbers out of these given numbers? We know that 2 is a prime number, 3 is a prime number, 4 is not a prime number because 4 has factors, and 5 is a prime number. Agreed? That means there are 3 prime numbers: prime number, prime number, and prime number. There are 3 prime numbers out of 4 possibilities. That means if we need to find the probability of prime, it means favorable outcomes. How many prime numbers were there? There were 3 prime numbers out of the 4. If we need to change it into percentage, we simply multiply it by 100%. And we say that 4 times 1 is 4 times 25, and 3 into 25%, and 3 into 25 comes out to be, there is a 75% chance that when you spin the spinner, the needle will land on a prime number. Do we agree on this? Okay. So let's have a look at another example. We know that a dice has 6 sides, right? A dice has how many possibilities? 6 sides. Then a dice will have 6 possibilities. Okay. Okay. Remember one thing. You flip a coin and you roll a dice. Okay. Coin is always flipped and the dice is always rolled. Let's say question number 3. They're asking us, find the probability of getting an odd number as a percentage. Okay. Okay, let's see. We know that the possibilities on a dice are, what are the possibilities on a dice? If we are looking at a die, okay, die is singular and dice is plural. Okay, so what are the possibilities on a die? We can get a 1, we can get a 2, we can get a 3, we can get a 4, we can get a 5, or we can, but we cannot get a 7, right? From 1 till 6, we can get any number as an outcome. If you roll a dice, it would land on any number out of these 6 numbers. Agreed? So out of these numbers, we have to find the probability of odd. How many numbers are even? Even numbers are divisible by 2, right? There were 3 even numbers and there are 3 odd numbers. Agreed? So if we need to find the probability of odd, that means How many were odd numbers? There were 3 odd numbers out of the total 6. That means it can be simplified to 1 upon 2. And if we need to change 1 upon 2 as a percentage, we simply multiply it by 100%. That means 100 upon 2%. That means it comes out to be. So we can also say in a statement, there is a 50% chance the die will land on an odd number. And the remaining 50% of the chance would be the die will land on an even number. Agreed? But we had to find it for the odd, so we simply write for the odd. Agreed? Any questions till now? If you have any questions, please do let me know. Okay. For the next question, they are saying you pick a marble at random. I will extend this question. The next question I'll extend. Question number 4. Okay. And they are asking us to write the probability of purple as a percentage. As a fraction, we can find, and fraction can be easily changed into a percentage. Okay. This is question number 4. How many marbles do we have? We have 1, 2, 3, and 4 marbles, right? Out of these 4 marbles, the marbles have different colors. So we can say we had 1 green, 2 purple, and one blue, right? And 1 blue marble. Agreed? So these are the marbles. So if I want to find the probability of a green, probability of a purple, or a probability of a blue, if we want to find the probability, how many greens were there? There was 1 green out of the total 4. Purple. How many purple marbles were there? There were 2 purple marbles out of the 4. How many blue marbles were there? There was 1 blue marble out of the 4. In the question, we need to find the probability of purple, which we already found. It came out to be 2 upon 4. That can be simplified to 1 upon 2. And when we change 1 upon 2 to a percentage, that becomes into 100%. That comes out to be 50%. So there is a 50% chance that if you pick a marble, it would be purple in color. Agreed? So if I extend the question and I say, just a moment, please, let me just copy this. The second part of the question, I'm saying, okay, the second part, let's say this is the first part of the question. This is the second part of the question, okay? And, okay. In the second part, if I say, what is the probability of getting a blue marble? What is the probability of getting a blue marble? So we know that we can find the probability. And to find the probability, what we can say is probability of blue would mean how many blue marbles were there? There was 1 blue out of 4. And if we need to change this into percentage, we say 1 upon 4 into 100%. That means 25% is the probability of blue. Agreed? That means 1/4 or 25% chance that if we pick a marble randomly, there is a 25% chance that it would be blue. Okay. For the next part, part C, if I would say, let's see, an orange. Part C, and I say, what is the probability of finding an orange marble? Out of these 4 marbles that we had over here, how many marbles were orange? So in order to find the probability of orange marbles, we know that the total number of marbles were 4, right? Out of these 4 marbles that we had in the question, how many marbles were orange? There were no orange, right? So that means it was a 0. That means 0 is the probability. That means we cannot select an orange marble because there are no orange marbles, right? And when we change 0 into 100%, that means 0% chance of orange. It's like if you are studying in grade, high job, perfect. If you're studying in grade 9s, right? What is the chance that you will pass the exam for grade 10s? 0% chance because you have not studied that topic, right? So if something is not present there, we cannot find it, right? If you're studying in a all boys school, right? If your class has all boys, 20 boys in it, and if you have to select a girl from the class, that means the probability of girl in your class would be 0, right? Because there's no girl in your class, all are boys. Similarly, out of these 4 marbles, yes, I know it's easy, step by step, right? So there were no orange. That means we cannot select an orange, right? Okay, let's have a look at another example. Okay, I would try to do 2. I will change question number 5 and we'll see something else. Okay, just a moment, please. We need to give our answer as a fraction or a simplified as a whole number. Okay, we cannot give answer as a whole number. We have to simply answer in a fraction. It can never be a whole number. Okay, if this is our question number 5, I'll make another copy of this so that we can reuse this. Okay, the first statement says your spinner is spun once. Okay, so we have only 2 options on the spinner, right? How many gaps do we have? We have 1, 2, 3, 4, and 5 partitions, right? So what we can find is we can only have red, 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 or yellow and yellow, right? 5 partitions. So what we can say is the probability of yellow. We know that the formula for the probability is favorable outcomes upon the total number of outcomes. Just let me copy this over here for reusing. We know that this was the way how we can find the probability of any given event by using this formula. Can we say we can find the probability by saying probability of yellow would be equals to how many yellows are there? There were 2 yellow out of the total 5. Agreed? Can we simplify this fraction? Can we simplify? It cannot be further simplified, right? So we say that the probability of yellow comes out to be 2 upon 5. That's already the answer, right? But if they say in the second part of the question, they say find the probability of getting red. What will be the probability of getting a red? That means probability of red would be how many red partitions were there? There were 3 partitions which were red out of the total 5. Agreed? Simple. Simple question. Now what I would try to do is I would just change one word and let's see what difference can it make. Okay, if we have green and red now, green and blue now. Okay, this is our question number 6. Let's suppose they are saying find the probability of a green. Rather than once, if I say you spin the spinner twice, what is the probability that both times the spinner spinner stops at green? Okay, we change the question totally. Now what is happening is, what we are trying to find is the spinner is spun twice. If you spin the spinner one time, what happens to the spinner? It can either be green or it can either be blue, right? It can be either green or it can be blue. So we can say that the probability of green, and we can find the probability of blue. How many green partitions were there? Just a moment, please. There were 3 green partitions out of 5. And for blue, there were 2 blue partitions out of 5, right? Because these were 1, 2, 3, 4, and 5 partitions, right? Agreed? What they are saying is, what is the probability? What is the probability both times the spinner stops at green? That means if we spin the spinner one time, it stops at green. Then we spin the spinner second time, it will again stop at green. Okay, so we have 2 ways to solve this, right? I will do one of the types over here. The representation of the data can be done through a tree diagram. Okay, we can represent the data. What happens is, if we spin, a tree diagram is like branches, right? It would be forming branches. If we spin the spinner, where can the spinner stop? The spinner will either stop at green, right? Or the spinner will stop at blue. There are no other options, right? If we spin the spinner, either we will get a green or we will get a blue. There is no other option. Agreed? Okay. If first time, let's suppose if you spin the spinner first time and it stops on green, right? Then you have to spin again, right? Then you have to spin the spinner again. So now this time what happens is when you have to spin the spinner again, it still has two options. It can stop at green or it can stop at blue, because spinner, the options on the spinner are not changing, right? Similarly, if the first time the spinner stops at, if the first time the spinner stops at blue and you spin it again, that means when you spin the spinner again, there are only two options on the spinner, blue and green and blue, right? So what we can say over here is we can have green and green. We can have green and blue. Agreed? We can have blue and green, and we can have blue and blue, right? Okay, what we need to see over here is green and blue and green would look like the same to us, right? They would seem similar to us. But the difference is that if me and you, we got the first and the second position in the class, right? If the teacher says A and B, if I am A, you are B, right? If A and B got the first and the second position in the class, but teacher did not specifically say who is getting the first position or who's getting the second position, right? If I get the first position, then automatically you get the second position, right? But if we reverse the scenario, if you get the first position, then I will get the second position, right? That means selecting green first, then a blue is not the same as selecting a blue first, then a green. They were two different scenarios, okay? Agreed? So what we can say over here is, what's the probability of green? Green was 3 over 5. Blue was 2 over 5. Green was, on the branch of green we write 3 over 5, on the branch of blue we write 2 over 5. Green was 3 over 5 and 2 over 5, right? And the question said that we need to find the probability that both the outcomes are green and green. We are saying and over here. Whenever we are using the term and means multiplication. The first one is green and the second one is green, right? So what was the probability for green? The probability for green was 3 upon 5 multiplied by the probability for the second green was 3 over 5. That means 9 over 25. And this means that if we repeat this experiment, right? Experiment was spinning the spinner twice, right? If we repeat this experiment 25 times, then there is a chance, then there is 9 times of there is 9 times possibility of getting both greens, right? G stands for green, right? So if we do this experiment 25 times, 9 times it's possible that both will come out to be green, right? If I continue with the question, if I make it a little difficult, if this was part A, if I say find the probability that both the outcomes are different. Different means if first time we are getting a head, sorry, green, then we should have a blue, right? Or if on the first we are getting a blue, the second one we should get a green. Agreed? What was the probability of green? Either we can have this as an option, green blue, or blue green, because both the outcomes are different. If first is green, second is blue. If first was blue, then the second one would be green. The probability of green was 3 over 5. Probability of blue was 2 over 5. Or means this or this, right? Blue was 2 over 5 into 3 over 5, right? This means 6 upon 25 and 6 upon 25. Okay. If you spin the spinner twice only, can you get both the answers? Can you get green blue or blue green? You cannot get both the answer. Green blue and blue green are the possibilities that you can get, but you will get one of the answers only, right? Either you will get green blue or you will get blue green. One of the options will be your final answer, right? See, let's consider you spin the spinner and it lands on green. Okay, then you spin again, it lands on blue, right? But if I spin the spinner, it lands on blue. Then I spin it again, it lands on green. So I can have blue green, you can have green blue. These are the only two options, but one of them would be the answer, right? So OR refers to addition. This or this. That means 12 upon 25 is the probability that both the outcomes are different. That means if we do this experiment of spinning the spinner twice, 25 times, there is a 12 times of chance that both the colors would be different, right? So through probability, we find the chance. Okay. Let's see what else do we have. Okay, let's do one more question, then we'll do the questions from the test. Okay, just a moment, please. For question number 7, it says, if you pick a card at random. Random means any card can be selected. There are 3 cards there. They are numbered 1, 2, and 3. Right? What is the probability of getting a card that has less than 3? Okay. Less than 3 means we can have the 3 numbers. How many numbers are less than 3? We can get 1 or 2, right? So what was the problem? How many possibilities are there? Less than 3? There were 2 possibilities out of the total 3. We can get either a 1 or we can get a 2. But we cannot get a 3, right? Agreed? So we simply write, okay, if for the next question, if I say, what is the probability of finding, just a moment, please. This was part A. Let's suppose this is part B. What is probability of finding an even number? So how many even numbers are there out of these three numbers? Yes. Thank you, Sam. How about even numbers? How many numbers are even? There are how many even numbers out of 1, 2, and 3? There's a single even number, right? This is the only even number. That means favorable outcome. There's one even out of the three cards. 1 upon 3. Do we agree? Okay. I'm not doing very difficult questions. I'm just trying to explain the logic over here, right? Because this is just the starting of theoretical probability. As we move ahead, the topics will get difficult. Okay. Grade 9, chapter 10. Just a moment, please. Okay. And the test. So let's do a few questions from the test and let's see. Okay. The same question that we just did is there. And let's see what would be the answer. It's exactly the same question, right? I'll try to change a value. I cannot even hide it. It's right there on the screen. If you pick a card at random, okay, this is our question number 1 from the test. It says we have 3 possibilities, 1, 2, and 3. We need to find the probability of a number less than 3. 1A and 1B. Cannot. I need to go sequence wise. This is the lesson number 2. As we move on with the lessons, it would get difficult. I'll give you a question at the end as a practice. You can do that question, okay? Less than 3 means there were 2 numbers which were less than 3. That means 2 out of 3 and 1A is the answer, right? I cannot be teaching one student. I need to take as the lesson is being planned for generalized, right? It's a generalized lesson right now. Okay. For the next question, it says, what is the probability of selecting a yellow? Question number 2. Would it be 2A or 2B? How many numbers are possible over here? We have 1, 2, sorry. We have 2, 3, 4, 5, 6, 7, 8. That means the total probability is 8. And how many were yellow? Yes, perfect. That means 2 were less than 3, right? For question number 2, we need to find the probability of yellow. How many yellow were there? There were 2 yellows. Perfect. But we have to give it as a percentage, right? We need to give our answer as a percentage. 2 upon 8 would be equals to, very nice, because we reduced it to 1 upon 4, and 1 upon 4 always equals to 25%. Thank you. Thank you, Sam. 25. These are just clickable questions, right? Very simple. Sometimes you would not even have to solve them. 25. Thank you. In question number 3, very simple. Question number 3, the answer would be A or B. We have a dice. We need to look for odd. 1, 3, 5 are odd numbers, right? Simple. That means 3 out of 6 were odd. That is 1 upon 2 is equals to. These are simple questions, right? That would be. Thank you. See, I'll leave it to this because we were just doing the theoretical right now. We are not doing the questions, okay? As we move on with the different lessons, we will change the questions and we will do more difficult questions, okay? Thank you, Sam. Please do try to complete the questions for the test that you have over here, okay? Take care. Best of luck. Have a nice day. Bye.